Hey everyone, welcome to this explainer. Okay, so today we're tackling a super common yet totally crucial programming puzzle. How do we get a computer to find the greatest of four numbers using Python? Sounds like a breeze, right? But honestly, it's going to reveal the absolute core of how programming logic actually works. Look at these four numbers, 12, 45, 78, and 23. If I ask you right now which one is the biggest, your brain instantly snaps to 78, right? Literally takes you less than a second. But here's the crazy thing about computers. They don't have that intuition. To a machine, those are just meaningless symbols. It needs us to feed it explicit step-by-step logic to figure it out. So, here's the game plan for this explainer. First up, we're breaking down the concept and logic. Then, we'll dive straight into the Python coding. And finally, I've got a really cool bonus shortcut for you at the end. Okay, let's dive right into section 1, the concept and logic, or basically how a computer thinks. To translate how we think into computer logic, let's imagine four kids in a race. We'll call our racers A, B, C, and D, and give them our numbers as their scores. So A gets 12, B gets 45, C gets 78, and D gets 23. We gotta find the winner. Now, since our computer can't just scan the list and pick the biggest one like we do, it has to act like this incredibly meticulous judge. It systematically compares the kids' scores one by one. So, the computer's internal monologue goes something like this. Step 1. Is A the biggest? Meaning, did A beat B, C, and D? If not, it jumps to step 2. What about B? Did B score the highest? If no, on to step 3. What about C? And if A, B, and C all strike out, the computer hits step 4 and realizes, hey, by process of elimination, the winner absolutely must be D. In the coding world, this whole process of elimination, we call that using conditional statements. Which perfectly brings us to section 2, Python coding. Let's translate that logic into code. To actually build this thing, we only need a few core Python tools. First off, the input function to ask the user for the numbers, and the int function to turn those inputs into actual integers. And guys, this is absolutely crucial. Because input always grabs information as text, we have to wrap it in int so it becomes a pure number the computer can actually do math with. After that, we're just using our decision makers, the keywords if, elif, else, and the and operator. Let's zero in on that and operator for a sec. It's a logical tool where every single connected condition has to be true at the exact same time. Think back to our racers, right? For racer A to take home the gold, A has to be bigger than B, and A has to be bigger than C, and A has to be bigger than D. All three comparisons have to be true simultaneously. If even one of them drops the ball and is false, the whole thing fails. A is not the winner. So what if A isn't the winner? Well, enter elif. It's basically Python's super clever shorthand for else if. This is how the computer moves down the line. It's like it's saying, okay, that first check was a bust, let's try the next one. If A didn't win, the program uses elif to check B. And if B's a no-go, it just throws in another elif to check C. And then we have else. Think of else as your automatic fallback, the ultimate catch-all. Look at the logic here. If we checked racer A, not the biggest. Checked B, nope. Checked C, still nope. Do we really need to waste time checking D? Absolutely not. By pure logic, D wins by default. That else block just triggers when all those previous statements are false, which saves us from writing a bunch of pointless code. Let's ground this with another super relatable example to see how it handles real-life data. Imagine a teacher trying to find the top student in a class of 4. We've got Rahal with 56 marks, Aman with 78, Neha with 88, and Priya with 67. Our if, elif, and else setup acts exactly like that teacher. It evaluates Rahal, skips down to Aman, checks Neha, and boom, correctly spots her as the topper with 88 marks. And there we go, success! By chaining if, elif, and else together, the program nails the greatest number every single time. Honestly, it's so satisfying to watch it run. You've basically just taught a machine how to deduce the right answer, making it perfectly mirror human logic. All right, let's move on to section 3, the bonus shortcut. This is the smart pro method I promised you. It's actually pretty wild to compare these two methods side by side. On the one hand, you've got the long logic method. That's the multi-line block we just mapped out step by step. But then you have the short method. I mean, look how elegant that is. It's literally just one line of code using Python's built-in max function. You just toss your numbers into the brackets, and Python does all the heavy lifting behind the scenes. But here is the absolute crucial takeaway for today. Yes, max is an incredible shortcut, and pros use it constantly to save time.
But when you're learning, mastering that underlying if and else foundation is what actually makes you a programmer. Think about it. A computer doesn't naturally know what to do. Someone somewhere had to write the underlying logic that makes that max function work in the first place. By doing it the long way, you're fundamentally rewiring your brain to think algorithmically.
Which brings us to a really fascinating thought to leave you with. Now that you've got this super fast max shortcut in your toolkit, when do you think building out the long-form logic with if and else is actually still the better move? Think about those complex scenarios where maybe you need to know not just which number is the biggest, but why, or maybe what actions need to trigger if there's a tie for first place. Keep chewing on that, keep building those logic muscles, and thanks so much for joining me on this explainer. Catch you next time.